Hello there, my name's Vince from My Mate Vince and welcome to yet another fixing video. And in this video today, we're not just fixing one thing, we're going to fix multiple things. Low voltage, high voltage and petrol. So sit back, relax and enjoy.
V8 engines, no brum brum.
Change of scenery today. We are at Windsor Racecourse Marina and we're on Brian's boat. This one here you probably have seen before in a previous video when I was working on it with Brian. This is currently for sale. He's got a new boat that I haven't seen until today, so I'll show you around that later. It's a lot more roomy on the inside. This is currently for sale. It's down as 28,500. I think the price might be reduced from that now, and it is a Princess 286 Riviera Cassell. So he's having problems starting the boat, and it could be because it's been for sale for a while and he's wondering if the fuel has gone off in the carbs. So we're going to try to get it started. Worst case scenario, might have to take the carbs off and he might be stripping them down. I don't think that's going to be in this video, but also on his other new boat there's work to do as well. So I thought I'd film it. It might be a little bit of fun. Let's see if we can get this beast roaring again. You should see the size of the engines. When I walked in here today, there was a cat asleep on here. So there's been a cat living here for a bit. Right, let me show you these engines. So here are the two engines. They're 5-litre Volvo Penta V8s. Look at the size of them. And Brian's just going to try to start. Is it that one now, the left one?
The left one, yeah, starboard, I think. Okay, ready?
Yep.
Nothing. Try the battery thing again, Tony.
Two, yeah?
Yeah. Oh, something's just happened there.
Oh, here we go. That's that one. Does it sound weak on turnover though, no?
Yeah, it's a little bit low, but they normally... Let's try the start the right one. Okay, try the other one. Oh, they are a bit low, aren't they?
This is irrelevant now, isn't it? Yeah.
Yeah, the top,
Yeah.
I've de-winterized it.
So we're going to be spraying some carb cleaner in to begin with, is that right?
No, easy start.
No, easy start, right, okay. So just taking off the air filter.
So the choke's not on. That's the choke plate there.
Okay.
That's interesting. Have you got some easy start?
It's
in the trolley pull. The choke should be like
Oh, no,
this
here.
to start it. So what I might ask you to do is hold this. Oh, that's it now.
going to be trying here now. Is that what you're using?
Yeah,
Yeah.
easy start. In fact, I might
I
ask.
think you spray it while you start it.
Yeah,
right?
I think you might.
Yeah.
Yeah, Tony, you can. So accelerate a little bit, about a third.
That first.
Yeah,
We're doing left or the right one?
this one here, the left.
It's on the third anyway.
See, the choke's not.
So it's left as you're driving, so it's left as if you're facing this way. It sounds weak though, doesn't
Yeah,
it?
it does. Now, I think this battery here starts the engines. Yeah. So I could put a jump onto this battery here.
Have you got a multimeter here, Bri?
I brought one, yeah.
Is the battery strong?
Let's have a look. 1 second, where did I do it, boy?
14 volt.
14 volts.
So that should really, unless it's the wrong, unless it's the other batteries over here.
Oh, close.
Oh, most of that.
Battery seems a bit weak. I'm going to check it on the.
Oh.
That's very slow.
Yeah, I'll have to get that.
Well, it's plugged into charge, though, isn't it?
Yeah, it is.
So it shouldn't be doing that.
It should be charged, but it's going to take a while to charge it, isn't it?
Ah.
That's the cat.
No light on that, is there?
Sorry, mate.
Right, battery charger's reading 30 amps, mate, which
Yeah.
means that's not good, so it's putting in 30 amps.
Okay.
So, you know, it's probably a 30 amp charger,
I've got one of those smart
which would
chargers.
suggest that the batteries aren't great.
Right.
13, yeah. 13 volts now. It
Right.
must be that.
Oh,
then.
but it's 13 volts because it's on charge though, isn't it?
Yes.
Yeah.
I think I need to get some jump leads on.
Yeah, I've got a jump pack to be fair.
Have you?
Yeah.
Just got a booster back here because the battery's low. Oh, it smells nice. I like that smell.
Beautiful, isn't it?
Yeah.
Do I have to turn it on from here?
Yeah, just on the front there, twist 90
I'll
degrees.
I've got to keep it away from the pulleys.
Yeah, of course. Oh, I'm not doing anything until you say yes.
Okay, I'm ready to go, mate.
Yeah, it's definitely on. You turned it to the right.
Yes, I've turned to the right, yeah.
Cool, alright. Let's try without start first.
Okay.
That's really quick, isn't it?
Yeah.
That's right.
Yeah.
Yay. Oh.
It will
Ah,
stop.
but it's dragging through fresh fuel, is it? I'll just quickly say this now. I know it's obvious to 99.9% of you, but there's always some. Please do not copy what you see in this video. These are massive engines with plenty of moving parts. If Brian was to slip or faint while wearing his happy St. Patrick's Day t-shirt, even though it's coming up to the end of May, then he would be mangled in these huge engines. Obviously, the safe way to do this is to have the hatch down so you're nowhere near any moving parts while attempting to start these engines. Saying that, it's going to be very hard to spray the easy start in there if the hatch is closed. But I'll say it anyway, do not copy what you see in my videos, take them purely for entertainment. Never copy what you see in any one of my videos because there's plenty of things that are going to be unsafe and incorrect. Anyway, let's get back to trying to get these V8 beasts started. That's it. But do you think that there was purely on the easy start then?
No.
No.
I'll say a little bit's getting through.
Yeah.
This will start without it. Let's go, put the top on that one. Maybe go through
Put the top on.
So what you see here goes on for maybe another hour or so. Keep using the easy start and we do actually get the engines running, but they're just not happy. So as you're looking at the engine, that's the engine on the left and the engine on the right, but actually that's not how they're worded. So the engine on the right is actually the port engine, which is the engine on the left, and the engine on the left is actually the starboard engine, which is the engine on the right as far as boat terminology is concerned. But just to make the video easy, we're just saying as we look at the engines. So as you're looking at the engine now, the one on the left hand side does run, but it's a bit cranky starting. It can be turning over quite a while before it decides to fire, so it's definitely not happy. Now the one on the right is weird. It will tick over and start quite nice, so it will idle quite nice and it will start quite nice, but yet as soon as you give it any acceleration it cuts out. So the engine on the left has a new carburetor, the engine on the right that cuts out has the old carburetor. So we're thinking this is to do with gummed up fuel because the boat's been sat for quite a while, and fuel, modern fuels, do go off relatively quickly apparently. So we're wondering if we strip down the carburetors, will we see a load of old fuel? Now annoyingly, the engine which is hard to start, the one with the new carburetor, the one that's the left engine as you look at it, but really the starboard engine, that one there is clean on the inside. Can't see anything wrong with it at all. It looks absolutely fine. That doesn't have any sort of like jelly-like material. Everything seems to move okay. So let's pick up the video now as we're about to work on the original carburetor, the old carburetor, because it's already strange how one carburetor has been changed and the other one hasn't, because you think they would wear at pretty much the same time. But anyway, maybe some damage was caused to one of them at one stage and it was just replaced. So we're picking up the video now where we're going to work on the old original carburettor on the engine which fails as you floor it. So it ticks over fine but fails as you floor it. And let's see if we have any horrible, dirty, gummed up fuel on the inside. Look at that. This is the one that lives on the boats. What a life. She's so friendly. I bet she gets sport rotten around here. So we got this one off now, so we're going to take off the top and see if this one looks gummed up. Right, so this is it all stripped down, well the top half anyway, and everything just looks fine. It's definitely dirtier than the other carburettor. Slight bit more build up of carbon, and you can see it's older. It does say on the top that it's a Rochester, so there is a name on it. But I can't see any jelly or anything. You know, all these little things here, they all look to be clear. So if I was to hold it up to the light, you can see right the way through it. I haven't sprayed anything yet, so we're just going to use carb cleaner everywhere, but I'm not sure if this is the issue or not. On this one we actually took out the little needle here from the bottom, but again it looks fine. Right, just popping it back together, it's actually gone together really smooth and taken apart smooth. It's a lot easier the second time you do something. Notice though that on this one, which Brian thinks is an accelerator, did you say?
I think it's accelerator pump. I think
accelerator pump too.
But I might be wrong.
Yeah, but the other one had a spring on here, and this one there is no spring on here. But it's still sprung from the inside, but the other one had a spring to help it go. Unless, of course, this is made different. It is a different, looks a different carburettor. It does want to come out, doesn't it? Yeah. Do you know what? I'll spray in there as well. Well, everyone thinks that may be air rather than fuel related, so we're not going to spray that because the carb cleaner does kind of disintegrate the gloves a bit, so it might do damage to the diaphragm on the inside. Right, Brian's gone AWOL, so he might know more about this than us, but as far as I can see, you're going to have a spring on here to, you know, get it back into position, but this is like the throttle, yeah? So when you do this, that's going to work fine, but the spring's broken here, but even without that, there doesn't seem to be any strength to this mechanism here. It doesn't seem to want to go in one position or the other. It's just flapping around doing nothing, and this, I think, is to do with the choke, and maybe the reason is it's not revving is because it's always open or always closed. So it might be like too rich or too lean, and that's why it's okay on idle, but when you go to accelerate, maybe something needs to move here to open to allow more air in, and maybe this is getting starved and just cutting out. This doesn't appear to be doing anything, so this is just flapping around. Look at that, it's just flapping around in the wind. So I'm not really sure what's going on. You think that when this is energized it might do something? I don't think the last one did though, because the last one
had an electric choke.
Right, okay. On the last one, when we did this, it seemed to open up on full throttle. It seemed to open up this as well.
Right.
That moved round.
Yes.
So you reckon maybe when we put power in here, that something might harden up in here and then move this?
Maybe.
Yeah. I think we're going to have to look at the other carburettor and see what it's doing.
Yeah.
Right, maybe this is just to do with the rough starting, but you know I said this was flapping around in the winds. Well look, if we mimic a spring with my brother's finger here, you can see that when we move it, for example, from here, that it wants to go back, does it? Yeah. So if you put a bit more pressure on that there, and that would mimic a spring. So it looks like there would have been a spring, but maybe this is just to do with cold starting and nothing to do with the acceleration side of things. But I think it might be related. So we need a spring to go on here. Now just to prove whether or not it is the spring, what we could do is refit the carburettor, and if we were just to maybe cable tie between here around the fuel inlet bit here, then it's going to hold it in that position. Because I'm thinking with gravity it's just sat like that, and that's why there's a problem. But if we were to do that, then it might start running fine even on the acceleration. Brian was just saying that he thinks under normal operation it should be like that, and when the choke's on, because there's an automatic choke, that it should be like this, which is choking the engine like that. So instead of cable tying it that way, maybe we should cable tie this for the time being here, and that way then that forces it open. But then I'm thinking that gravity would have just gone like that anyway. So now I'm not so sure if it's got anything to do with that, even though I still think there should definitely be a spring here. We've also taken out the air mixture screw, obviously counting half turns. It was 14 half turns out. We sprayed right the way through. There's a tiny bit of black on this, but very little, and the spray goes right the way through into there. So that one looks fine. We'll do the same on this one, but everything looks really very clean. Took a picture and let AI bring some other pictures up, and look here, no spring. So this one has no spring at all. Weird, the same as this one here. And also there's no mark where the spring would have been. My brother Paul was just saying that maybe it sucks it and brings this one in, which then would bring this in, like so, which stops it from, you know, closing. We're going to put it back on and see if it behaves any differently. We've given it all a clean. So the carb is back on. Let's see now, will it make any difference or not? And also, once it's running, we want to see if that choke thing is flapping around. Should we give it a go?
Start up. No acceleration?
Oh yeah, I'd give it a little bit, yeah. I'll give it about a third turning.
Hands clear?
Just needs to get fuel, so then we will know.
So that choke is wide open at the moment.
They're well built engines in cars, aren't they?
Yeah.
The Americans don't like all of the against the European stuff, all the plasticky and the...
Yeah.
Robust.
It is very, yeah. And it came apart really easy as well. Yeah. Is the choke quite solid? The flap? Yeah.
Seems to be okay.
Okay. Well, unfortunately, we've been at it all day, and yeah, this one was working okay, but I bet when we try it now, it won't be. This one here does seem to start at the moment, but then when you give it some throttle, it will cut out. So we'll start with this one here, and you'll see it will start all right.
Which one? The left one?
Yeah. So it starts nice, and we have had it running for a bit, but now if we go to accelerate, it will like backfire and then cut out. There you go. So that is still playing up. And now if we do the right-hand engine. And that was running okay before we were messing with that one. So that does at this moment in time seem to be okay, but it has been very hit and miss throughout the day. So we are going to call it a day for today. It's been a big waste of time, yet an enjoyable waste of time. It's nice tinkering around on these boats. It's a lovely environment. You're in with nature. It's just a very pleasant place to be. So I quickly want to show you the inside of Brian's new boat. It's another old boat, but it's a new one because it's amazing. It's not much bigger than this boat here, yet inside there's so much more room. If you had to live on a boat, you'd much rather his newer boat than this one. But once I showed you that, I'm then going to come back another day because Brian's buying some carb rebuild kits, and we're going to rebuild these carburetors because all we've done today is clean them. To us it looks like a carburetor problem because there seems to just be problems with the fuel side of things. So he's going to get some new rebuild kits. We're going to come back in a couple of weeks' time and we're going to rebuild these carbs, and hopefully after we've rebuilt them they'll be purring away lovely again. Anyway, have a look at the new boat. And this is Brian's new boat here. Didn't get to show you around it, but we'll come back another day. It's much bigger on the inside. Little step up there. I'll quickly show you around inside. So you've got this area all around here, so it can be driven up here. And then if we go down, it's huge inside. So you can drive it from here as well. So you've got all this area. And then you've got two doors that lead to the same bathroom. And then check this out. Look at the size of this down here. It's massive. So there's much more room on the inside, yet lengthwise I don't think there's much difference between the boats, but this is a lot taller. This boat's a lot higher up. I really like it inside.
2 weeks later.
We're back again in Windsor, a couple of weeks later now. Lovely day today. And Brian's got two repair kits for the carburetors. So pretty sure now that the reason that this one here didn't work when you put it on full throttle is it's got like different it's got like a fast throttle thing in the carburetor, and looking back it did look like there was a bit of corrosion down by the ball bearing. So we're thinking, we've got some little cocktail sticks, we're thinking of trying to get that ball bearing out, clean that out, and then putting a new carb kit in. Hopefully then everything should run as it should do. So I've got my trusted screwdriver, going to strip it down, and then we'll have a closer look on the inside and hopefully get this working. So if we look in this bit here, and I think that that's the bit to do with when you put the throttle open, have a look there. Let me try to zoom in. Can you see it looks like the bottom of the spring has left itself behind? So if you look at this side here, so you need to be looking at this bit here, you can see it looks like there's a kind of a bit of metal going over that hole there. You perfectly see it there now. I don't think that should be there. Right, I've got a little cocktail stick here. I'm going to see if it moves.
You're filming this bit. See that bit there, Vince?
It definitely feels like it's a metal. See,
Feel like it's
There's
moving.
two holes. Right.
see,
I'll find that
I
bit.
think, Brian, it looks like there's a bit of metal blocking that, and I don't know if that metal should be there or
No,
not.
it shouldn't be. There should be one's an aluminium ball, and the other one's a normal ball. I was watching the video and it's all funny enough. Let's have a look. Yeah, some of them have got two holes. You're right.
There we go. Hold on. Oh, no, that looks, no, that's proper. Do you reckon, is that? Oh, is that the bottom of the spring? Hold on a minute.
Yeah.
Hold on a minute. Or is it supposed to be there?
No, that's the bottom of the spring. Definitely, because I didn't see him pulling that out of the video. He did pull a ball bearing out.
That looks a bit big for the bottom of the spring. Maybe that's supposed to
Bear
be
in mind,
there.
it might not be that spring.
Yeah,
This has been, look, that looks quite new. Maybe it's been serviced and that's been left in behind afterwards.
Do you know what? That looks like a new one. You're right.
Maybe.
Having said that, you don't know. I mean, it could be 10 years old and never deteriorate either. Do you know what I mean?
Yeah.
It's not in a hostile environment, you know. But
Well, I've pulled that out from the bottom, but maybe that's supposed to be in there. Maybe that is like a circlip, which I initially thought to hold a ball bearing in. Or maybe it's the bottom of the spring, but it looks a bit big. But like my brother just said, maybe it's been replaced. I mean, if you look at the size of this here, maybe it can take a slightly bigger spring, and maybe that was the bottom of the old spring, because it does look like the right diameter. And maybe that was what was stopping the ball bearing from moving up and down, possibly. So let's turn it out and see if the ball bearing now comes out. there it is. So that's the ball bearing there. So hopefully that was stopping when you floored it. Hopefully that was stopping this from moving, which caused the engine to cut out. Right, we're going to start cleaning things up and putting things back together. Well, Brian's found this really good video here, Charles Price Vintage Speed Rochester, YouTube Charles Price 7897. So we're just going to watch through it and you know, replace things as we go along, because he's already said that there's two ball bearings, one's steel, one's aluminium. I didn't even know there was a difference, so we've got to make sure we put the aluminium one in the correct place. Brian's got these here, which are quite nice, and also these, they look like tiny little pipe cleaners in all different sizes. And then you can get the ones that you can put them through here. They clean up the holes then. Now, these things have a tiny, I thought it might be stained, but it looks like the ends are rubber to probably make a better seal where the petrol comes in. They do come in the kit. So using Charles Price's video, I'm just going through bit by bit. And then my brother finds this in the instructions off another carb kit. I thought Brian just bought 2 carb kits. He also bought a third one. The third one seems to be more relevant to this carburetor, and it had instructions with it. And look what he found in the exploded diagram.
Robin, no better off.
Unfortunately, this here isn't the bottom of the spring. We were looking to see is there a replacement spring in the kit, and there's not. And then we're looking at the exploded diagram here, and you can clearly see 48 here is that little bottom of the spring. So it is supposed to be there. So 47 is the spring, 49 is the ball bearing, and 48 is that kind of, must be like a little retaining thing at the bottom. So we're not quite sure now why it's not working. Well, isn't that a shame? So we cannot find anything wrong with it whatsoever. Anyway, we rebuild the carburetor. There's definitely wear on this one. When it comes to the little air fuel, little needle type cone, there's definitely a bit of wear on that. We tried to adjust the air fuel mixture by screwing in a quarter of a turn, screwing out a quarter of a turn, trying it over and over again, screwing it all the way in, unscrewing it 2 turns, and then going a quarter turn, and another quarter turn, another quarter turn, etc. And it just makes no difference. The engines just run horribly. They're just so hit and miss, and they're really hard to fault find because it's hit and miss. Sometimes it will start and idle beautifully, other times it will be hunting all over the place. We're now wondering, could it maybe be an automatic choke problem? Because apparently in cars from the same sort of era, 80s and 90s, a lot of people disconnected their automatic chokes because of the problems they caused. So if this is from the same era, maybe the automatic chokes are playing up. We're really not too sure. Unfortunately, we have to admit defeat. This is our second day on it, and there's 4 of us here. Yes, we're having a bit of a laugh and we're chatting and doing other stuff as well, but we are trying to get this working, and none of us can get our heads around it. We have to, unfortunately, leave this up to the professionals. Maybe the carburetors are just worn. So it might not need a rebuild. You could be putting some new part in this, but if the carburetor body itself is worn, then it's not going to make a difference. Obviously, if you were rebuilding these for a living, you would know them inside out. We don't, and we've really done our very best on it. So unfortunately, the engines are no better than they were before. Well, they're a bit better. You can get them to start. But no, if you leave these another week or 2, the fuel's going to evaporate off, and then you're going to have to use the that cold start stuff again. So yeah, these are definitely not operating as they should be, because even 30, 40 years ago, people wouldn't have been waiting there 10, 15, 20 minutes trying to get their engines started. It just wouldn't have happened. So yeah, unfortunately, a big waste of time, but strangely an enjoyable waste of time. Let me just finish up this part of the video. So unfortunately we have to admit defeat because we're not really any closer. They both run, but they both run bad. thinking it's a carburetor problem, but not 100% sure. The fault seemed to follow the carburetor, but everything's been so hit and miss from the very beginning to the end that nothing's really been conclusive. So both carburetors are going to come home with us, and then I think Brian's going to pay somebody to rebuild them, and then if they can't be rebuilt because, let's say, that one might be too worn, obviously that's a new one, then at least he might be able to be advised, and then he can buy some new carburetors, because we haven't really made any progress. So unfortunately it's been a bit of a nothingness video. Hopefully you might have still got some enjoyment from it. If you've got anything that may help, put it down in the comment section, and maybe then we can do a revisit with this boat working nicely again.
Odd behavior.
I'm going to try to fix up this power bank with a really strange fault. Right now this is completely dead. If I press the button or double press it for the light or plug something into it, nothing happens. Yet this power bank will have charge in, and the way I get it working again is nothing happening. The way I get it working is to start charging it, and as soon as I charge it, it will then say something like 70%. So I fixed this years and years ago. It was a problem with one of the battery tabs, I think, where it connected to the board. It was a bad connection. And since then it's been to various different festivals with my son, daughter, etc. And then recently I've been going up to my son's room and this has been completely dead. And I'm like, you know, don't let it do that. Always leave some charge in it, because if you discharge something, then leave it for a couple of months, then it goes below the safe level and then it's complete junk. Or I have to take it apart and try to put charge in, but it's, you know, it's dangerous. It's not good for the battery. But he's saying to me that it just stops charging. So, you know, it'll be 100% and then plug it in, and then he'll look later and it will just have stopped charging. And the last couple of times I've been monitoring this, and that's exactly what's happening. So watch this now. If I use this power bank and then go in here, look at that. What percentage are we going to be on? 76%. Yeah. Now it will start working absolutely fine. Watch. See, light comes on. Isn't that weird? Light goes off. Light comes on. Light goes off. I'll let that go off the screen, and then I'll show when I plug it into here and hit the button that it will start working. There, gone off. Plug it in here, and now hit this button. Oh, it came on automatically. Yeah, and right now it's going to be charging. There you go, 74%, 47 minutes until full. So how weird is that? Now, it's unusable at the moment because it's unreliable. I can't take it anywhere. You can't rely on it because you need another battery charger to charge this one up. So let's take it apart and see if there's anything obvious on the inside. So taking it apart is a complete headache. It always was hard to get into because it's clipped all the way around. But last time I worked on it, I must have used a bit of super glue on the tabs because it is really hard to get into this time. I think I probably was thinking that I'm not going to be going into this again because I fixed the fault that was originally there. Now, if you're wondering, can you just reset this by holding down the power button? I tried that. Doesn't make a difference. Also, you might be wondering if you were to use the lead in on itself, so from the USB-C to the USB-A with one lead, would that work from USB-A out into USB-C in, or out of USB-C into USB-A? It makes no difference. The only way to liven this up is to use a separate power bank or a separate power supply to get it working. You can't charge it in on itself. So it takes me about 15 minutes of prying to get into this. Everything's a complete mess, but this is unusable as it is. I need to get into it. Even if I completely ruin it, I still need to get into it to see why it failed. Luckily there is a bit of a gap before you get to the battery, so I don't think I'm prizing on the battery. Right, there we go. I think I can't see any glue. Do you know what? I reckon I put dots of super glue on each of the tabs and this big sticky thing going across, and that's what made it so hard. You know, when I fixed it first time, you just think to yourself, you want it working, you probably don't think that it's going to come apart again. So we are free. So that was the original break that had gone there, and that still appears to be... Right, no, that's broken now. Right, so it seems to have locked itself up again. even when I'm putting pressure down on that battery. I don't think the battery was a problem, because when it was working all the time, but that was the original problem there. Not sure, don't know now. Let me tell you what we're going to do. Let's plug this in. Let's give it a little charge. So hold that down there, plug that in, and now let's unplug it. Right, that works. Now I'm going to let go of this so it's gone. Now when I put it back, will it come? Yeah. So let's say if I was to let go of that now, so pretend there was an intermittent break on here, because that clearly, when I took it apart now, but I did lift the battery up, you know, and that could have broken it then. Right, now let's do it. No. I wonder whether or not, maybe, could that be it? Could there be an intermittent one here, where it's just barely hanging on, and if you were to drop it, it might have, you know, lifted for a split, well, say a split second, but what's going to push it down again? Don't know now. 1 and 2 and 3 and 4 and 5. So that's still working. 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. And now it's not working. So it takes time for a capacitor on the inside to discharge. Once it's discharged, it's lost it. I suppose that would be the most obvious thing, that maybe the connection was iffy, because I mean it's broken now that I've taken it apart. And then once it breaks, it needs to be, you know, once it's gone for 10 seconds, it will now never work. It will need to be reset. Let's just see how many seconds it is. One and 2 and 3 and 4 and 5 and 6. It's gone. Okay. One and 2 and 3 and 4. 1 and 2 and 3 and 4 and 5. Yes, it's about 4 to 5 seconds where it's gone. Well, let's have a close look at the board and see if there's anything that doesn't look right. Let's see if there's any kind of cracked solder joints or anything like that. I'm using plastic because remember, the battery is going to keep connecting and disconnecting on the other side. So I don't want to use metal and short something out. Well, everything I think looks good that side. Well, the very fact then that there's nothing on Google about it says that it's not a common problem, meaning that it must be just this original fault here then. So I'm going to add solder this time, because you shouldn't be adding solder heat near here, but you can see that my spot welder wasn't strong enough to get through last time. You can see what it finished the video working, but clearly it's broken. So I'm going to solder it this time. Do not copy what you see in my videos. I'm going to apply solder to here, and then heat up this here, push it down. Hopefully that will be good, and then I'm going to put hot glue on top of that. But you need to use a spot welder because you shouldn't be putting heat anywhere near these batteries. Remember, they can go up in flames. They're lithium, they're dangerous. I now think though that this is I think maybe this was the problem, because we've kind of proved it, because right now even if I do this here, you can see it will not come back alive. We have to plug it in for a few seconds and then it will come back alive. So obviously it resets something. And if I do that for more than 5 seconds, 3, 4, 5, push it back, now it doesn't work again. Oh, okay, hold on. 1, 2, 3, 4, 5, 6. What? 1, 2, 3, 4, 5, 6, 7. There you go. Yeah. It's weird how it flashes every now and then though. Right, here goes. Do not copy what you see in my videos. This is quite thick, this top bit here, so that's why the spot welder is probably not strong enough to get through that thickness. I don't mind leaving it on the board for a long time because I'm actually quite a distance away from the battery there. So I'm going to be putting the majority on this side. There, that should be... Oh, do you know what? That bottom bit came off there. The whole pad came off. Should I take off the whole thing? Yeah, why not? Don't need so many layers, do I? Mind you, that is a nice blanket there. No, that's good. I'm going to leave that. There's probably numerous layers on here for the spot welding. Right, now I'm going to add a lot to here. But I'm going to be quicker on this bit. Because this is the bit that is actually connected to the battery. There we go, it's a nice big ball on it there. Now I'm going to force that down and heat up the board, and hopefully I'll get the board heated up now. So let's get that all big pillow nice and done, and now let's force this down. Oh no, it doesn't want to go. Hold on. Let's use plastic. No, plastic's a bad idea because it's melting. And down you go. I'm going to keep it held there until it all solidifies. There we go. Now that is definitely on there. Can you see we have one from the top and one from the bottom battery? And they're in there, they're going to be, that's plus there, and I can't see this one. They're going to be in parallel with each other, aren't they? So that's why you've got so much strength here. You haven't just got the one battery, you've got two. So you've still got the same amount of voltage coming out, but it's just going to last a lot longer. So if it was just one battery, my spot welder probably would have done that, no problem. But because it's two, it's I think it was a little bit thick. Anyway, I know it looks a mess, but that is on there. I'm going to add glue as well when it's back into place. Let's add a little bit of isopropyl alcohol. Give it a little clean up. So my original repair lasted however long that video was out. I'm going to say about a year, and I'm going to say probably 2 years ago now. So it did all right, but it clearly wasn't a very good fix. Well, I say that, any fix is better than no fix, because it wasn't working to begin with. Anyway, all I have to do now is put it back together. I'm editing this up about a week later. It's been working fine ever since. So I have to put it back together. I'm going to put hot glue on both of the terminals. If I need to get into it again in the future, well, the glue's easy to come off if you use something like isopropyl alcohol. The odds of getting into this again is going to be quite slim, because I've made such a mess of the case that I epoxy it to begin with, but the epoxy doesn't stick very well because I haven't really got much meat left now. It's mostly just the case. All the clips are mostly broken. It's just, imagine a lid trying to close on a box. There's not much surface area there on the uprights. So what I use is JB Weld plastic bonder. This stuff is amazing. I've used it quite a few times. The problem is I've never had to get back into an item I've used plastic bonder on. I think it would probably need to be Dremeled off. So I'd probably have to Dremel this in half to get into it again. But My son uses this. My daughter uses this one. I've got quite a few power banks. And I don't want the chance of the lid coming off. I'd rather render the product useless in the future rather than then take it to a festival and then the lid falls off, they keep on using it, somebody drops something on it, pierces the battery and it goes up in flames. So I want the power bank to be sealed well. So the plastic bonder might be overkill, but in my instance it's not, because at least I know now it's going to be as strong as it was when it left the factory to begin with, if not stronger, because it was clipped to begin with and now it's properly glued all the way around. So this plastic bonder does take a long time to go off, but I'm going to show you this now. I did charge up my phone, it charged up my phone fine, and I have been using this since editing up this part of the video. I'm just going to show you this in live real time now as of editing. The plastic bonder is amazing. When you first of all use it, it's quite tacky and you think to yourself, oh no, you know, it's never really going to go off, but it does. It goes rock hard and smooth plastic. So let me show you it now, and it really is miracle stuff. JB Weld, if you're watching, you can sponsor me. Right, so this is it here. My son's been using it, I've been using it as well, and if you have a look, when you turn it on here, you can see it's working. And the finish, although it looks horrible, it's not tacky. Listen. Yeah, so that's the original, and that's the plastic bonder. It feels just as hard, so it takes a while for the tackiness to go, but then after a day or two, you'll find that the tackiness is gone, and now that's not going to stain anything. If you put that in a rucksack or rub it against the carpet, it's not rubbing off on that. So I really like it. Now, to make it look nicer, I was thinking, because it goes on very thick, I was thinking if you were to get some masking tape, like some sort of like painter's tape, frog tape or something, and maybe put it around here, spend a bit of time doing it nicely and doing it around this bit here, and then you just leave exposed the actual gap that you want to fill, and also maybe a few mil, 2 mil either side of it. Then if you put it on, at least you're then going to have a nice line top and bottom. Yes, it's still going to be bumpy, so when you look at it this way, it's not going to be smooth, because I think it's going to be too kind of gooey to smooth out, unless you were to get it just as it was starting to go off, but maybe you'd mess with the strength. But I think then it would look a lot better. So for me, it's a proper functioning one, and if my son and daughter didn't want to use that, I would happily use that myself. Right, let's move on to the next item.
Oh, look at you.
In this video today, we're going to try to fix up this U-Green fast charger, 65 watt. Looks brand new, but it is completely dead. So you can see my lead is working because I've got it plugged into here, and you can see we have a little charge symbol there. Yet when I move this from here, this is USB-C, and plug it into this port, it does nothing, and this port, it does nothing as well. Yet when we plug it into here, it will start working. There we go. Now, obviously this is going to be very, very, very hard to take apart. I can see it's sealed around here. Probably going to be kind of welded or something, but we'll get it in the vise, give it a squeeze. You never know, if I can get a bit of a spudger in there, I might be able to lever it out. Should be interesting to find out why it's not working. Is it going to be on the primary high voltage side, or is it going to be on the secondary lower voltage side? And if you're wondering how much this fancy charger is $21.99, reduced from £30. Let's see if we can get it working. Now, this is not going to be fun to get into. I'm going to try to the vise, and I'm going to try to squeeze it here. See if it will do any tiny bit of opening. Apparently Petrol is good to open up these things, but I'm not going to mess around with Petrol because my hands would be ruined and the house would stink. So that should put quite a bit of pressure now, opening it this way, I think. So maybe if I was to try to get in here, maybe give it a few taps. I wonder, would I be able to break? It's going to look nothing like it does now. It will be all mashed up. Oh, here we go. That actually went in more than I thought it would. Yeah, here. That bit there. Oh, look at that. Look at that. It did go in a good few mil, which is promising, but it was still an absolute nightmare because yes, it goes in there, it doesn't really go anywhere else. I am just prizing and prizing and prizing and forcing it and forcing it and forcing it. After about 5 to 10 minutes, it does eventually pop itself out, but it's not easy. Of course it's not easy, because unless you're going to screw it down, these things are glued. They can't just come apart in somebody's hand because somebody could get electrocuted. Yes, excellent. We are in. Not too bad. You can see it's glued all the way around there, here, or like some sort of welding or something, plastic welding, bonding. Now let's see why this is not working. Obviously I've got to be really careful. Looks black there, but that might be just the coating off here. Let's zoom in a bit. The board's labelled up as U green. There. Oh, this thing's blown off here, look. What I presume is the bridge rectifier, is it? No, I don't know what that is. Well, there's been an explosion in this corner here. I don't actually know what that is. Right, how are we going to get this out? Yeah, so it's all burnt up here. Oh, whoa, Vince. Unless that was me levering it up and something else has burnt. Hold on 1 second now. Where is the burning? Oh, the burning's coming from this side. That there was me levering because I was going in the side, wasn't I? So that was me levering it up. Okay, that isn't actually disastrous because I might be able to fix that. But it looks like the burning's actually coming from in here. This side here. So we definitely have to get this out. Still doesn't want to come out. Probably knock another 10 components off. I've cleared these, so I should be able to get this out. Come on. Such a tight fit. Here we go. Yes. Whoa. Wow. Proper explosion. Right, let's check these massive caps to begin with. Is that on the primary? I can't really even see. Anyway, let's just check them for voltage. Don't think there's anything. Oh, 17 volts there on that one. But there's nothing on here. Nothing there. Nothing there. But we do have 17 volts there. Right, I'm just going to short that with these here. There you go, tiny little spark. Now let's just make sure there's no voltage there. I presume they're the main caps, but I really don't know. Right. I'm going to take some pictures so I know where to put the thermal pads back. It is incredibly compact. Ah, right, I think this is the, look at the difference there. You can see where the bridge rectifier was and all the burning around it. So we are coming in, I presume, on these 2 points. Something I think used to be here, possibly. Did that used to be a fuse? Well, let's get some isopropyl on it, see what's going down.
So something would have caused a fuse to go. Let's see if we can work out what that is. Right, let's zoom right the way in. I can see some marking there, but it's half rubbed off. Right, I think that is T315 amp 250 volts. Okay, so it's not working clearly because the fuse is not here, but what took the fuse out? Should we check the bridge rectifier, which is this one here? So this is the AC, can you see the little wave there? And this is DC, negative and positive. So let's check that. Well, first of all, maybe we should see if there's some sort of short. Hold on now. So we have this to here, yes, and this to here. If we were to go there, there's nothing there. I don't think there's any short there. Right, let's check the bridge rectifier. So I'm going to go on diode test. Let's see if we have any shorts. Normal, 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 I think. Swap the leads. Normal, normal, normal. So we have a reading one way and not the other way. I think that bridge rectifier is okay. I think that is okay. Should we see if we have any shorts on the capacitors? No, I think that's the main cap. I wonder, what are these ones here? They're 400 volts. Can't even see what that one is. Ah, we've got a short across the cap. Interesting. So we have a full short across the caps. So that's the same as me putting my leads together. So if I went on to continuity, not on this one here, but can you see on these ones? If I'm honest with you, I don't know why we've got 3 caps. So something has shorted. I don't think I'm going to be putting this back into service, but let's see what if we can work out what the problem was. Because it's so compact, this is what makes it hard to work on. Right, how do I unsolder that? Is it just these 3? So if I can take that out, it might give me a clue on what's the other side of this, because we do have a short on this one here, between the negative here and this one here. So if I can unsolder this, I can pull it out, I might be able to see what's the other side of the board. Also, it allows me to eliminate this board as well. Here it comes. Aha! Right, so let's see if the short is still on that board, and at least then we can eliminate things. Presume it will be. Oh, we've got the negative going straight down from here. Oh, hold on. Weird. So we have the negative going down from here, but we've also got the negative. So we've got the kind of like AC negative going down, but then we've got the DC negative and positive from the bridge rectifier going down. So it could maybe be a problem on this board, I think. So let's see now, do we still have a short on these caps? We do. So this goes round to here. So we have a short between... What? Not there? Where does that go? Hold on. Why have they done that? Wait a minute. That goes to there. Does it go anywhere else? Confused. Let's clean it.
No, that doesn't go on that track. That track is from there. So where does that go to? Oh, it feeds the top. Does it? Huh? What I'm on about is this one here. This, you see the track goes down here and it doesn't go, as far as I can see, anywhere else. That negative goes straight to here, yeah? Unless it does something on this side that I can't see. Don't think so. So it goes straight to here, which is like that. Like that. And from what I can see, there's nothing on this side. That's not soldered to there, is it? That's just there. And here, which isn't connected to there. What on earth? Where do you go to? What on earth's that about? Well, I'm already very confused. Because how is the circuit getting its neutral? Go around here. A second. How is this being fed? Must be here. There. Here. Well, I'm not very good at power supplies. This I'm already struggling because I can't understand what's happening. Oh, it goes off here. It goes up this way. Yeah, it goes off in this direction here. So maybe this is nothing. Maybe it's for another model, but on this one it doesn't do anything. You can see it goes off in this direction. So I presume it probably goes through. Oh, do you know what? But it goes straight to here, this thing. Well, no, that's a mystery to me. Everything's burnt. Look at this track, it's blackened. In fact, it's completely burnt through. So if you have a listen, we got this to here. So that's the reason it's not coming up anywhere. Got it to here, but it's not coming to here. Yeah. So now that probably is, if I was to go here, that is going to be coming up somewhere there. Okay. So far we need a new fuse. We need to replace the track from here to here. I think that part there might be okay once that bit's fixed. So let's go back to here. What's causing the short? Could it be this thing? So hard to look around the board. Maybe I should unsolder the caps. It might give me a bit more view of this. I'm wondering if this has actually gone short. I want to know what that is. And is that this thing here? I think it is. We do not have a short on. Unless one of the caps has failed, but I think that would be unlikely. I think my short's gone. I think my short has gone. Look. Why has it gone? What did I do? Move that? I moved that thing, didn't I? I also wiggled the caps. Ah, my short's gone. I haven't even got an ohm reading. I don't think. No. Jabbing in there good. Right, okay, let's start unsoldering stuff. Maybe it will become obvious. I mean, something caused it to have a catastrophic failure. And this is still on the DC mains, isn't it? Because it comes in via the bridge rectifier here, and this coil thing is going across. Unless the coil had a direct short rather than an ohm reading. But mind you, no, because I haven't got a... Sorry, it was a complete short, wasn't it? And now I haven't got anything, unless I've broken a wire somewhere. Let's unsolder some of the caps. I can't find a fault that's not there now. But maybe if it was powered on, it might come back. And while I'm doing that, I will shout out the My Mate Vince Massive. The members this month are Keymon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeebs.com, DJ VG, Pigsy, Russ Melanson, Rickard Bergland, Shamsa Al Swadi, Stuart Park, Stephen from the Broken Past on YouTube, Lee Benz, AJ Computer Services UK, Chris Bayans, Victor B, Garen Shaw, and Lady Leona Drury. Massive thanks to each and every one of you. Now that these capacitors are out, let's give them a quick check and see if they are shorted, see if the shorts come back. There's no shorts on them now. So, what could have caused the short? So I'm a bit confused. This coil thing here goes between here and here to feed this rail, but then this rail goes up all the way along here somewhere, doesn't it? So it's very hard to see because we've got this hard white gloop everywhere, so I scraped that off and I have a closer look at the main chip. I've actually cleaned that off better than I thought I would be able to. So it is a SC1936C07 MAP 35325B. Let me just Google that. Well, I think this is the brains behind the operation. So it says here, it's this is what it is. Flyback switcher IC, integrated primary switch, synchronous rectification, and flux link feedback. Never heard of that before. Right, it says it dramatically simplifies the design and manufacture of flyback power converters, particularly those requiring high efficiency or compact size. Well, it certainly is a compact size. It incorporates primary and secondary controllers and safety rated feedback into a single IC. And it's got line over, under voltage protection, output over voltage and over current limiting, over temperature shutdown. Devices available that support the common combinations of latching and auto restart behaviors required by applications such as quick charge and USB PD power delivery designs. I think the devices are available with and without cable drop compensation. Right, so I think that is the that's going to be the main chip. Let's see if the shorts come back now that I've been scraping around the place. It's annoying that it's just disappeared. See, there's nothing there now. Unless... No. I keep coming back to that, but that's just blown open. So I'll test a few more things on the board, a few diodes and stuff like that, and I can't find this short because the short's not there anymore. But we know that that coil with the heat shrink on it is blown open. It's going to be a bit of wire wrapped around like this ferrite core. So as far as a multimeter is concerned, we should have a direct short there, and we haven't. So then I unsolder that component to see whether that shows me anything. Now, why are you not working? You should be just a coil of wire. Should you not? Around a kind of ferrite bead type thing. So here and here. You are open. Why are you open? Do you know what? I think the transformer's shorted. And I think, not now, but I think it was. And I think by me wobbling something, I got rid of the short. I think the transformer's shorted and it's just taken out everything. This is just a coil of wire. So this should really be a direct short. It wouldn't be, but you know, it's doing something, but on my meter it should be a direct short. Right, let's see where you're gone. Oh, there we go. Look, it's all gone here. It's burnt through here. There, you're gone. That wasn't me. Okay, so you're gone there. Should we take out their transformer? I mean, I could bring that round, but then I've changed the kind of like inductance of it, haven't I? Or I could even solder it up and remove one wrap. You know what I mean? Anyway, let's leave it for the time being. It's very burnt here. Mind you, it's burnt everywhere. Yeah, look here. This bit here is even burnt through. Can you see here? I don't know, is that the component next to it that did that? Because it is the right height. Oh, hold on. You don't think that shorted on that, do you? Let's see, 1 second now. It's a bit, or did it just burn? Wait a minute, wait a minute, wait a minute. Zoom out. I think we might be getting somewhere. Was that rubbing against that causing, because this is enamelled, but it could have worn through. Let's just see. So let's put the burn. The burn's here. Yeah, so that there is to do the burn, and that is going to be rubbing against that there. Ah, hold on now, hold on. Then when I moved it, I got rid of the short. It was a full short between here, because look, this is going to be, let's go back to continuity. I think we're getting somewhere. This is going to be going to here. There, yeah. And I bet this here is a ground. So let's go on to the negative, which is, this is the negative, I think. I'm not too sure. Let me just see something. Here. There. I think we've proved what it is. So what's happened is, this shorted, because look, you see this top rail? This is, the top rail is where the coil was, yeah? The coil's between here and here. So this then, the coil here, yeah? This here was shorted via this rail with this thing here. So that goes to there. We've worked it out. This, and all because of the evidence of using your eyes and looking at that without any skill. So this goes to here, yeah? And this one goes to here. So we had a short through here on this here. And we'll probably find that if we went onto this side, that it's shorting up here. There. There. Okay, we have proved it. So now, was it a fault, or when it was installed, where's this gone? Do you reckon as this was pushed, I think as this was pushed down, it might have rubbed against, because that kind of, it doesn't really look burnt, it looks more mechanical. I think from the very beginning that was sat there, pushed against that. So I think if we were just to bodge this up, I'm not going to put this back in service, if we were to bodge this up, I think we might be able to get something out of it, even if it's just a bang. So I spent the next 30 or 40 minutes trying to get this back together. I resolder up that enamelled damaged coil here and put a little bit of heat shrink around the damaged bit of the wire, because remember the enamel's gone because I've soldered it now. I don't want it to short against anything. And I fix up the bit that I pried off at the very beginning, that weird capacitor, I think it might be, the massive capacitor that I pried off at the very beginning to try to get in it. I also redo that track. I also have to find a fuse, but all my fuses are big. I don't know what fuse would have been here. I mean, I've got loads of fuses, and they're either square type, cylinder type, or they come with little legs on them, so you can do like through hole soldering. This one here is tiny, and it's like an SMD fuse that just, I mean, I've got resettable fuses that I used on a Philips Sonicare once. I'm thinking it used something like that, but not a resettable one, just a kind of normal fuse, but it must be an SMD type one. So yeah, I do all that and then put it back together. I'm actually quite confident it might work, because we found the problem. We found that from manufacture, this thing never worked. From manufacture, this was pushed down, and I think mechanically the sheath got damaged against the transformer, and then from that moment on it shorted, and then as soon as it was plugged in, you've got a direct short between the positive from the bridge rectifier and the negative from the bridge rectifier. But the bridge rectifier itself didn't break, but there obviously is a catastrophic failure, because you can see the burnt charring everywhere, and also one of the tracks is completely vaporized where the neutral wire comes into the item. So it takes quite a while to do all this. I'm not doing this to put it back in service. It'd be just nice to see it working at the end of this part of the video, because then I can show you it working, and 100% then it shows that was the fault. I mean, we know that was the fault because we can use our eyes, and it makes sense. The short went as soon as I wiggled this coil. The reason the short disappeared is because I physically removed the coil from shorting against the transformer. So yeah, it's just unfortunate. Maybe when this left U-green, it might have worked. It could have been dropped in transit, and there might have been just a slight movement on that coil, because it's quite a heavy device with the ferrite core there. There might have just been a slight movement that just made it just barely touch. Either that, or it might have been touching and the enamelled wire would have been insulating it, but maybe with a little bit of vibrations throughout a week of using this, it then might have gone bang. So it looks brand new, but it is possible it might have had a tiny bit of use. But I think it could well have just shorted the very first time it was plugged in. Anyway, it's back together. I haven't glued it or anything like that. It's back together. I want to show you a new toy that I've bought. So I've got myself a dim light tester thing, a dim bulb tester. The idea is that if this has a short on, I think it lights up the bulbs rather than blows, for example, the fuse that I've just put in. So eventually it will probably pay for itself. I paid a lot of money for it, but it does look very nice. I think I paid 70 something pound, I think it was. While obviously you could make these for probably £10, but this does look good. You ready? So I think the idea is that you leave it like this, and then you plug this into here, like so, and then turn it on. So I'll turn it on now. When I do this, if there's a short in here, I think these two light up, and then it won't blow the fuse. I think that's the idea. If I was to do this, I think it puts full power straight through to here without the bulbs. Right, here we go. First time using it. So that's off there. I'm going to plug it in. Hopefully it won't go bang. I'm going to stand back because I'm very nervous. You ready? Let's see if it's going to go bang. Oh, wow. That's good. That's good. Okay. Turn that off. That's good. Do you reckon it's going to work? Let's plug in. What am I going to do here? Because I don't want to risk blowing anything up. Well, I'll tell you what we can do. Why don't we plug this into here and see if it comes alive. You ready? Standing back again. Come on. Oh no, you're not coming alive. Oh. Oh, I thought it was actually going to work. Well, that's disappointing. Oh, I actually thought that might work. Hope I'm doing this correct. The very first time I did it though, they came on for a split second, did they not? Well, at least I got to show off my dim bulb tester, and I think, although it is a failure video, I personally think it was quite interesting, because I do believe that was an installation problem when this was made. I think when that was put down, it kind of rubbed against that metal thing, and I think then it was against there, and maybe it did work for a while, but maybe with a bit of vibrations, or maybe even the forcing off it down might have just rubbed it, you know, it caught the outer bit of the coil, you know, this thing, and rubbed against the enamel on the inside, exposing it, which put a direct short. So we had a direct short between the bridge rectifier, didn't we, on the positive and the negative off the bridge rectifier. Coming out of that, we had a direct short, which blew up quite a lot. Which makes you think, why on earth is that bridge rectifier still working? See, it's a little bit hard for me to test. I'm now thinking maybe the bridge rectifier's gone. I think it's pointless. We know what the fault was, and I'm not putting it back in service. And it could be one of many different things. Bridge rectifier was testing okay, but I don't believe it was. I tell you what we could do very carefully. I'm not plugged in at the moment. We could go on to here to see if we do have the DC voltage. So let's do that. Because those two bits, that was after the bridge rectifier, so we should have like 300 volts or whatever it is DC. So I am going to turn this on so I don't have to touch that. Plugging it in now. Again, standing back. Turn it on. Hasn't gone bang. Let's go carefully without touching anything else onto here and here. There we go. We do, we have 336 volts. So I have fixed the primary side there, you know, the primary side there. Let's go on to the capacitors that originally were shorted. Here and, careful Vince. Yeah, there we go. So I fixed the bit that I did, I fixed that coil and stuff appears to be working. So it's something, you know, it's something, it could well be just something on the secondary side. And now it's dissipating down. Well, there we have it. The bit that I did, I think is probably okay, but for all I know, that chip could have taken the brunt of it or something like that.
To sum up, my mate Vince is rubbish.
Well, there we have it for this video. Unfortunately, only one working item out of 3, which is a bit of a shame, but if you don't try, you never know. And not everything is always easy. Sometimes things can be hard. So this one is working fine. Doesn't look the best, but it's definitely working fine. This one, in my opinion, is beyond repair, because even if you do spend quite a bit of money and time fixing the inside of it, you're still going to be worried about maybe this back bit falling off and exposing mains inside there. So I'd always be wary about fixing something like that. But in my opinion, I think that had catastrophic damage, and there could be numerous chips gone inside that one. And as far as the boat will be fixed. Obviously, it's worth putting more time into the boat than something like that. Weirdly, since I've come back from that boat, I am so tempted, because I know I'd probably get a bit of a mate's rate offer on that boat there, and I think it could potentially make some fun videos as a My Mate Vince project. The thing that's holding me back isn't so much the price of it, because the boat's always going to hold a bit of value. It's the fact that I'm going to have to probably pay £500-ish more in fees, and then there's these other costs involved with owning a boat as well, having to get, I don't know, safety certificates and stuff like that every so often. So I think I'd be causing myself a major headache. I found the Rolls-Royce quite stressful. I think this would probably be next level stress, but still, you never know, it is a little bit tempting. Anyway, hopefully you got some enjoyment from the video. If you did, give it a massive thumbs up. Hopefully next time I'm working on something, I will have more success. But then, one thing out of 3 is better than nothing out of 3. Thanks for watching, everyone.